Dear students, myself Sujay Kumar, mathematics teacher, Modern English School, New Area. Today I discuss student the some difficult problem of elimination, exercise 13b. This is the last video of the elimination. So please student, take care and see here. Exercise 13b, question number 7. Some student asked to me, sir, please solve from exercise some important questions. So now in exercise 13b, remaining question, that is 7, and it is given that if tan theta plus sin theta is equal to m and tan theta minus sin theta is equal to n, and you have to prove that m square minus n square whole square is equal to 16m. So dear student, m is equal to tan theta plus sin theta. So m square is equal to tan theta plus sin theta whole square. So right here tan square plus sin square plus 2 tan theta into sin theta, because a plus b whole square, a square plus b square plus 2a. Similarly n is equal to tan theta minus sin theta, then n square, because there is n square, then it is tan theta minus sin theta whole square is equal to a square, that is tan square, plus b square, that is sin square, minus 2 tan theta into sin theta. And last step is m square minus n square. So m square minus n square, I substitute their value, then m square is tan square, sin square and 2 tan theta sin theta. But here is the minus, so value of this n square will be changed. Here is plus tan square theta, so I write here minus tan square theta. Here is plus sin square theta, I change into minus sin square theta. But here is minus 2 tan theta sin theta, and value is here is minus, so will be plus. So here is plus 2 tan theta into sin theta. So minus tan square plus tan square minus sin square plus sin square will be cancelled. So now your question is m square minus n square is equal to 2 tan theta plus 2 tan theta is equal to 4 tan theta into sin theta. And after that, squaring them, because your question is squaring them. So squaring them, m square minus n square whole square, then you get 16 tan theta into sin square theta. It is first equation and it is LHS. Now RHS is 16 mm. Only substitute value, then you get 16. M is tan theta plus sin theta, and n is tan theta minus sin theta. Then it is equal to 16 tan square theta minus sin square theta. It is 16. This tan you can write sin square theta by cos square theta minus sin square theta. You take 16, you take common LCM, that is cos square theta, and here is sin square theta minus sin square theta into cos square theta, because here is 1 divided cos square, that cos multiply sin, that is sin square into sin. Now we take common, that is 16, and sin square is common. What is remain? Here is 1 minus cos square, because sin square is common, then 1 minus cos square by cos square theta. What you get? You get 16. It is the value of tan. It is into, and it is the value of sin square. Second, and it is the RHS. So LH is 16 tan square theta sin square theta, and RHS is also 16 tan square theta sin square theta. So we can say LHS is equal to RHS. That is proved. See examples of 13. Question number 9. That is, if x sin q theta plus y cos q theta is equal to sin theta into cos theta, and x sin theta is equal to y cos theta. It is given. That means this line and x sin theta is equal to y cos theta are given, and you have to prove x square plus y square is equal to 1. That means you have found the value of x and y from the equations, these two equations. So now first you write that is x sin theta is equal to y cos theta. It is first equation, it is given that. And second equation is that x sin 2 theta plus y cos 2 theta is equal to sin theta into cos theta. I separate here, that is x sin theta and sin square theta. When you multiply, then you get this. So x sin theta common from x sin 2 theta plus y cos 2 theta. Then it is y cos theta into cos square theta. When you multiply, then you get this. Is equal to this is given. Now x sin theta and it is sin square theta, but this y cos theta we write y cos theta is equal to x sin theta. So this y cos theta written as x sin theta because both are equal. So I write here x sin theta. And next step, this x sin theta and x sin theta are the common between them. So we write common x sin theta. So remain here sin square theta plus cos square theta equal to sin theta into cos. Here is x sin theta and the value of this is 1 and it's equal to sin theta into cos theta. This sin theta and sin theta cancel. Then x is equal to sin theta. X is equal to cos theta. So x is equal to cos theta. It is third equation because first and second equation are there. Now the value of x put in the first equation. X is equal to cos theta. So you write here x is equal to cos theta into sin theta is equal to y cos theta. Now cos theta will be cancelled. So sin theta is equal to y. So your question is x square plus y square is equal to x is equal to cos square here given and y is equal to sin square. Then it is cos square plus sin square first identity and it is equal to 1, that is 4. Number 11, that is x is equal to r sin alpha into cos beta. Y is equal to r sin alpha into sin beta and z is equal to r cos alpha. And you have to prove that is x square plus y square plus z square is equal to r square. LHS is x square plus y square plus z square. So I write only LHS, that is x square plus y square plus z square. The value of x is put here, that is r sin alpha into cos beta and squaring them. Similarly plus y square, put their value r sin alpha sin beta, r sin alpha sin beta whole square plus z square, I put their value r cos alpha whole square. Next step, it is squaring this, then we get r square sin square alpha cos square beta plus r square sin square alpha sin square beta plus r square cos square alpha. There are three terms, but these two terms has common sin square alpha and r square. Find out here and this term r sin square alpha are the common. So we take common r square sin square alpha. So what is remain here? Cos square beta plus what is remain here? Sin square beta and plus right this r square cos square. Next step, it is r square sin square alpha, but the sin square beta plus cos square beta is 1. So I write here 1 and this is the multiplier. So write here 1 plus r square cos square alpha. Now r square is the common between them. So I write r square common. Then you write r square common, then sin square alpha plus cos square alpha in the bracket. And the value of sin square alpha plus cos square alpha is again 1. Then r square into 1 is equal to r square and that is RHS. So only substitute the value, you can find your solution. Now see question number 12. Very important questions for you. If cosec theta minus sin theta is equal to m and sec theta minus cos theta is equal to m, then prove that m square n to the power 2 by 3 plus mn square power 2 by 3 is equal to m. Dear student, first I write the value of m. It is equal to cosec theta minus sin theta. First you convert all the arithmetic part into sin and cos. So it is cosec theta minus sin theta. I change it. It is 1 by sin theta minus sin theta. LCM sin, that is 1 minus sin square theta by sin theta, and 1 minus sin square theta is equal to cos square theta by sin theta. It is the value of m. Similarly, n is the sec theta minus cos theta. Sec theta, right, 1 by cos theta minus cos theta. Again take LCM, that is cos theta, and it is 1 minus cos square theta, and 1 minus cos square is sin square theta by cos theta. So student, m is equal to cos square theta sin theta, and n is equal to sin square theta into by cos theta. Now your question is m square n power 2 by 3 and mn square to the power 2 by 3. First I find m square n. What is the value of m? Here, cos square by sin square. I write here cos square by sin to the power square, because here is m square into n. So I only substitute the value of n. N is sin square into sin square by cos. Now squaring them, then you get cos to the power 4, because cos square to the square is cos to the power 4 by sin square into sin square by cos. So this sin square and sin square cancel, and here is cos 4 theta, here is cos theta only, so here is cos 3 theta. So value of m square n is equal to cos to the power 3 theta. Similarly, you find the value of mn square, that is m n square power mn square is equal to m is cos square theta by sin theta into n square. So square you get sin 4 theta, because the square of sin square is sin 4 theta, and by cos square theta. The question is mn square, value of m is this and n square is this. Then cos square cancel, and this sin 4 divided by sin, then you get sin q theta. So value of mn square is sin q theta, and your question is m square n power 2 by 3 plus mn square to the power 2 by 3. This is the value of cos q theta power 2 by 3, and value of this is sin q theta power 2 by 3. Power to the power multiply, then you get cos square theta, and here you get sin square theta, and it is equal to 1. So it is your solution. So first you find the value m, then m square and multiply by n. Similarly, next and after that you get your solution cos square plus sin square, that is all. Friends, this question is exercise 13b. Some student asked me, please sir solve these questions, and it is also very important question for you. New book, that is 13. If sec theta plus tan theta is equal to p, then prove that three things. First, sec theta is equal to half p plus 1 by p. Second, tan theta is equal to half p minus 1 by p. And sin theta is equal to p square minus 1 by p square plus 1. So student, first what is given that? So we write here, that is sec theta plus tan theta is equal to p. It is given that, and we know that also, that is sec square theta minus tan square theta is equal to 1. It is the identities. So we write here a plus b sec theta plus tan theta and sec theta minus tan theta is equal to 1, because a square minus b square, I write a plus b and a minus. Now substitute the value of this. Okay, from equation first. So it is p into sec theta minus tan theta is equal to 1. So what is the value of sec theta minus tan theta? You get here 1 by 3. That is second equation. It is first equation and that is second equation. Now write here, it is sec theta plus tan theta is equal to p, and sec theta minus tan theta is equal to 1 by 2. There are two equations. By elimination method, we solve it. So you see here, it is plus sec and plus sec. Then it is 2 sec theta. But plus tan and minus tan will be cancelled. Is equal to p plus 1 by p. Then sec theta is equal to what? Sec theta is equal to p plus 1 by p. And these two go this side, this is 1 by p. And it is your solution. First, what is the sec theta? Sec theta is 1 by 2 p plus 1 by p. Second, tan theta. So again you write this, that is sec theta plus tan theta is equal to p, and sec theta minus tan theta is equal to 1 by p. For second questions, you subtract, then you get the value of tan. So please change the sign, plus, then it is minus, it is minus, then plus, it is plus, then minus. This sec will be cancelled, and it is 2 tan theta is equal to p minus 1 by p. So what is tan theta? Then tan theta is equal to 2 p minus 1 by p. And that is the second proof, that is tan theta is equal to half p minus 1 by p. In third, no any problem. Both equations you divide, then you get the value of third. How? First you write that is tan theta is equal to half p minus 1 by p, and divided by sec theta is equal to half p plus 1 by p. This half will be cancelled, and this tan theta is written as sin theta by cos theta, and it is 1 by cos theta. And here LCM with p, that is p square minus 1. Here LCM with p, that is p square plus 1. What you get here? Here is sin theta by cos theta into, here is 1 by cos, you write cos by 1 is equal to p square minus 1 by p into p square plus 1. This we cancel, cos cancel, then sin theta is equal to p square minus 1 by p square plus 1. That is your solution. So first solve these two, after that divide LHS and RHS, then you get third equation, that is sin theta is equal to p square minus 1 by p square plus 1. This is the last questions of elimination. If you have any problem, then ask to me, only then I give you. Thank you.